Welcome. In this short video, I'm going to present ReCoRe, Regularized Contrastive Representation Learning of World Model. This is a joint work between myself, Rudra, Harit, Stephen, and Roberto. Learning the environment dynamics in a self-supervised or supervised manner is known as world model, which enables planning in the imagination as well as improve the sample efficiency. However, even though current state-of-the-art world models works well on in-distribution test, they perform poorly on out-of-distribution generalization test, which is validated using visual point navigation tasks from the iGibson. However, when we replace the visual perception module of Dreamer V2 with grounding dyno, the result has been improved significantly. Inspired by the results of foundation model, in this work we ask, can we learn generalized representation with less training data and a smaller model, which is also good for the efficient adaptation to the downstream task? And to answer this question, we proposed ReCoRe, which has three major components. First, world model, which separates the representation and policy learning to help the generalization of the visual features. Second, contrastive learning, which enforces the invariance to the global context. And third, inspired by the causality, we propose a novel technique for the regularization, which we call intervention-invariant auxiliary tasks, to explicitly enforce the invariance and preserve the local detail. Now, I'm going to explain four major components of our proposed model ReCoRe. The first component is contrastive learning technique, which improves invariant global context representation. Second component, which is also the major contribution of this paper, is intervention invariant auxiliary task, which explicitly enforces the invariance as well as preserve the local details. The intervention can be image denoising, image masking, or data augmentation, and the auxiliary tasks can be depth prediction, image denoising, semantic segmentations, or object detection, which is dependent on the environment and tasks at hand. Our third component is world model, which learns the environment dynamics. That is, given the observation at time t and action at time t, we would like to use the recurrent neural module to predict the future observation. Our fourth component is a controller, which is learned using a standard actor-critics algorithm and the data generated by the world model synthetically in the imagination, which is given a observations, world model synthetically roll out this episode in the imaginations, and we use those data to train our controller. Hence, it is much more sample efficient. Given these changes, we experiment the ReCoRe in visual point navigation tasks from the iGibson in a out of distribution setting, and we can see that ReCoRe matches the grounding dyno with Dreamer V2 on 100k time steps, but it significantly outperforms on the 500k steps. Also, the similar results holds on the sim to real transfer of the perception model. For the in-distribution experiments, we chose Deep Mind Control Suite. We can see that just simply using the image denoising as an auxiliary task, ReCoRe performs on par with the other methods. This shows that ReCoRe is equally applicable to the environment where designing of the special intervention invariant auxiliary tasks is not possible or not available. However, when we use the semantic segmentals, which is much stronger invariant auxiliary tasks, the result has been improved significantly. Further, our evaluation study shows that designing the intervention invariant auxiliary task significantly improves the results of the world model. The more detail is in the paper. In summary, our proposed intervention invariant auxiliary task improves out of distribution and sim to real generalization of the world model, and stronger invariance auxiliary task improves the results further. Thank you.